How you going, guys? Curtis from Cutting Edge Engineering. So today's job, we have a dipper arm off a Forestry style machine in for some line boring. Not 100% sure on what brand of machine this is off. From what I can gather of the look of the arm, it's some style of fella buncher or tree harvesting or processing machine. That end up there would attach onto the boom that is attached to the excavator or whatever machine it is. And then this end has got the attachment on it. So whether it be a fella bunching attachment or it be a saw or a grab or a grapple, that's mounted up at this end. Judging by the size of the arm, like what materials it's been made out of and thicknesses, I'm going to assume this is going to be between a 25 and 30 ton machine. So another thing that indicates what this arm could be from or what style of machine it is the amount of pipe work that runs down the right hand side of the dipper arm. So we've got 8 pipes down there, so that'd be 4 pipes in, 4 pipes out, which would indicate that it would be a multi-function attachment that goes on the end. Problem we've got with the dipper arm at the moment is we've got some bushings that have come apart in the end of the arm and has actually done some damage to the bores. The bush on the right hand side is completely non-existent and the bush on the left hand side, 3/4 of it is missing. Judging by the state of everything in there, it looks like this end of the arm cops a hell of a flogging. Typically on a line bore repair on say an excavator or something like this, we will bore out the damaged bearing surfaces, we would then bore weld them and then machine them back to spec. But in this case, customer has told me it's very difficult to find parts for this machine. So to make things a little bit easier for our customer, we're gonna go with a standard off-the-shelf generic bush to be fitted back into the end of the dipper arm. And it is an oversized bush. So we won't need to do any welding on the ID. We're simply gonna bore it out to suit the generic bush. One of the other things I did put to the customer is that I did see that the bush that is still in here has got a grease groove through it and around it in multiple spots. That can be your best friend when it comes to greasing the joint, but when it comes to a very, very high impact or wear area, like this one is, it can be your worst enemy, because those grooves that have been machined in there will also act like a dotted line, and when they do start to wear out, they tend to fracture through those grease grooves and then the bush starts to come apart and then you've got a mess on your hands. To give you an idea on what the standard style bushes look like on the inside, we do have this one here as an example. It's not off this machine, it is off a totally different machine in a completely different circumstance of operation. Inside these bushes, they have got multiple machine surfaces to get grease around the pin and throughout the bushings. But as you can see by the inside of this bush, you do lose a lot of surface area and you are essentially weakening it, and you're actually removing a lot of material that really needs to be there in these high impact areas. The bush I have here is the generic bush we are going to be fitting to the end of the dipper arm. The things that are different with this is this has one grease port in to allow grease into the bush. It then has a center groove and 2 holes in it to allow grease into the bush, and that is it. There is no other material missing. This bush also has double the wall thickness, which will offer a great deal more support to the pin and the joint than a standard one would. So the other way we could get around putting grease grooves inside bushes is we could put grease through the pin and run a solid bush with no grease grooves in it at all. That is not, in my opinion, an upgrade, because when you drill a hole through a pin and then you drill a hole down through the pin to allow grease through the grease channel, that is essentially a dotted line for a crack to form and the pin to fail. I have remanufactured hundreds of pins since I've been here for customers that have had machines with that particular upgrade that have totally failed. So the first thing I need to do before I can start line boring this is I need to get the remnants of that bearing out. Fractured through the center one. So what I've done there is I used a welder to add material to the bush, and the reason for that was so it would shrink after it had cooled down. So there are a handful of ways to remove a bush. I couldn't pull it out with, say, a press or a porta power. The other alternative is you superheat them with, say, an oxyacetylene. Once it goes red hot, you let it cool and it will shrink down smaller than what it was before you started. They become easy to remove. Welding does the exact same thing. If you weld a small area of the bush, it will shrink after it cools down and you can simply just knock them out. So if you are going to attempt the welding method, make sure you know where your bush starts and your bush stops. Because I had a customer one day that decided he was going to do a repair by himself. You could do what he did, and he actually welded the bushes into the end of the job. And it took a job that should have taken a couple of hours and blew it out to over 2 days. If you're going to do it, clean everything up and make sure you know where things start and things stop so you don't create yourself a hell of a nightmare. Righto guys, so we're about to start the boring process. We're not going to try and take out massive amounts of material in a single pass. Because the bar has got no support through the center, it is about 800 mil between the bearing blocks. If I do try to take out a massive cut, it's just going to end up with chatter, vibration, we're going to end up damaging tools. So we'll take a mil out per pass until we clean it up, and then we'll finish at the size. And we're using our 12 mil tool holders with an ECGT insert. They seem to be the best thing that I have found that works really well for line boring.
adjust that tool.
Is this one homie?
Oh!
Get it.
Oh my goodness! His favorite!
Homeless.
The ball is all alone. Ready, get it!
Kill it. What you got?
Oh! Slipping on his slobber. Jesus. Oh. He's slipping over. Oh, homeless, just lay down.
Lay down.
Lay down.
Righto guys, so all of the line boring is now completed. We've bored the eye out to suit the bushes. We're about to install the bushes. We will be using liquid nitrogen to do a shrink fit. At this stage, the bore that we have machined is 0.1 of a mil smaller than the OD of our bush. So using liquid nitrogen, we're going to shrink that down over 0.1 of a mil in order to get that to be a slit fit. When you're fitting these, there is a very fine line between things being too tight and not tight enough. So I'm going to take a measurement of the bush as it stands now in the current temperature. After it's been in the liquid nitrogen and everything's frozen down, we'll then take another measurement just to show how much they actually can shrink. This is what we store our liquid nitrogen in. It is a lab grade 30 litre dewar or vessel. It doesn't go out in the field, so we don't really need the big heavy duty one with the big case and everything around it. It comes with a thermo blanket that just helps with keeping everything nice and cold and everything insulated. If it is unopened, it will hold and store liquid nitrogen for up to 260 days, but we never ever get anywhere near that sort of time frame. we're getting this filled every 2 to 3 weeks by our local liquid nitrogen supplier. And we do reuse our old liquid nitrogen. If we've got any left after we've done a job, we do tip it back into the vessel for another use. You wouldn't do that if you're working in a lab or in a hospitality or something like that, because liquid nitrogen is used in many different industries. One of the other cool things about liquid nitrogen dewars is they are basically a tank suspended within a tank. In between the two tanks is a cavity. They then pull a vacuum on that, seal that off, and what that does is that stops heat transfer going from the outside atmospheric pressure into the tank and burning off the liquid nitrogen. That is my understanding of how a dewar works. Something really important to remember when it comes to liquid nitrogen: these vessels don't actually hold pressure, they have a venting lid in them. The other vessels that the guys who deliver our liquid nitrogen to us, they have pressure relief valves on their entire system, because when liquid nitrogen is stored under pressure, it can explode. If you were to put it in a bottle of some nature and try and take some home for a lab experiment, it's probably going to blow your lunchbox apart. Only use the approved vessels for storage and the approved vessels for transport. So as you can see with the vessel, that is not a tight fitting lid, that is a self-venting lid. It is made from a styrofoam and it doesn't fit tightly into the vessel. It just sits in there and stops the liquid nitrogen from burning off. So I'm going to give this a bit of a preheat. You don't want to get things too hot when you're doing a preheat for bushings, because the hotter you get the job, the quicker the coal is pulled out of the bush. You can create a thermal crack in the bush. Not only that, if you put too much heat into the job you're trying to fit a bush to, the bush can then absorb that heat and you will essentially shrink it and pretty much destroy all the work you've just done. So you don't want them red hot, you just want them just the chill taken out of the material. It's a rule of thumb I've followed for years and it's always worked. Righto guys, so we just fitted the bushes, everything went exactly to plan. We didn't have anything bind up, nothing locked, didn't have to hit anything with a hammer. As you saw, I shrunk that bush 0.2 of a mil, which is about 1/8 thou. I did have a 0.1 of a mil interference fit on the OD of the bush to the bore. So we did shrink it well beyond what I had machined it to. Because I could shrink it 0.2, doesn't mean I would make it a 0.2 interference fit, because the ID of the bush has a 0.15 clearance on it. Something that needs to be remembered when doing such things like this: always measure the ID of your bush and make sure you don't make the OD too tight, because you will then make the ID too tight and it'll have to be honed or machined to size. A general rule of thumb that I have followed forever: if I have to machine out a 100mm OD bush, I will give it 0.1 of a mil interference fit, which is 1 thou per inch across the face of the bush. 1 thou per inch is a good rule of thumb for something like this. It's never let me down. Something else we're going to do while we've got the liquid nitrogen out, I've got a brass bush I use for another job. We're going to throw that in the liquid nitrogen. So we'll get an OD measurement, we'll freeze it down, and then we'll take a measurement of that. Righto guys, so you just saw how much the brass shrank. It shrank 0.3 of a mil. So the brass generally shrinks 1.5 times the rate of steel. So if you would like to put a lot more crush on brass, you can, but there are a lot of other materials used as bushings and bearings that can also be shrank even more than brass and steel. Generally, aluminium will shrink about 3 times the rate of steel. It's because it is a softer material and it seems to disperse heat and cold very, very differently. And there are a lot of materials you shouldn't freeze down, like sintered bearings, which are a self-lubricated bearing. They don't like it and it does actually ruin them. This is the result of something that has been frozen in liquid nitrogen and then left out in the atmosphere. So it will create little icicles on it that you can just skim off the top. Once this bushing thaws out, we can put it back on the shelf and use it on another job. Don't really want to do this too many times because you can actually mess up the structure of the material if you freeze it, then heat it, freeze it and heat it. There's one more thing I need to do. I haven't done it for a lot of years. I'm going to freeze a banana and attempt to hammer a nail in with it. I have a broken pallet here I'm going to try and repair.
Oh no! Oh. Poor banana. It's still good. Can you use that much?
Try it. Oh.
The banana was too frozen.
Righto, so I left my banana, in my liquid nitrogen for a little bit too long and it actually shattered when I started to use it as a hammer. I would not recommend what I'm doing here, although I have used this stuff for years and I do use the proper gloves which have got a woolen inner and they are pretty impervious to liquid nitrogen freezing them and hurting you or hurting your fingers. I do wear safety glasses, so it's quite a safe environment here. It is a little bit of fun, but liquid nitrogen is no joke. If you get a drop of that in your eye, it will freeze any moisture it comes in contact to and it can blind you. It's one of those chemicals you shouldn't play with, so don't try this at home. Righto guys, so the job's done. Everything went to plan, so we're gonna get this one back to our customer, and thanks for watching. My hat on straight?
Yeah, okay, go.
Are you ready?
Yep. Am I too close?
I don't know, I think so. This could be a fella bunch of style. Oh fuck, I've lost it. Woo! Down through the surface of the material, down through the surface of the, fuck. Fuck. Oh fuck. Oh fuck. Oh fuck. Fuck. In my opinion, that is the worst idea man has ever come up with. Terrible idea. Stop doing it. Yeah. Right, what was I starting with?
And judging by.
And judging by.
So the other thing that indicates.
Okay, indicates, that's a great word.
Okay, thank you. Yep. For multiple.
What?
Well, I don't know what a frickin' fellabuncher thing is.
Okay, that can be your best friend when it comes to greasing.
Is it under that pile?
No, it's a fucking ruler ghost. Fucking rulers growing legs and popped off. It is dangerous shit.
It might explode in there.
Oh, shit.
Exploding banana.
I think the banana's having a bad time.
Hang on. It's just croak.
Pressure.
Shut up, trains.
It does have a thermal blanket on it to keep everything a little bit cold. Oh, duh. It's, oh, fuck. Right. So we, right. Ready?
No, okay.
Come on, train. Come and interrupt this so I can stop. It's not fun. This isn't fun. Right, so that is my understanding of how a dewar works. I'm not a rocket surgeon. I have never cut one apart to see what actually happens inside them. So until I break this one, I'm just going to leave it alone. So that's how a dewar works, I think. Fucking slobber.
I think he's dribbling. Yeah, he is. He's dribbling. Must kill Ducky. Poor ball. Oh my god. Jesus. Poor Ducky.